Hello, welcome back to the channel. I hope you're all on good form. I've just left the office and I'm heading to a customer handover. We do a customer handover with the customers post-commissioning, so the engineers that are on site will do a physical commission, which is where they set the heat pump parameters up, they balance the system, check the delta T across the radiators, do an appliance function check, and make sure everything is hunky-dory. And then I will go, or one of the other engineers will go to site, check everything over, give it a once-over, and answer any questions to the customer, as well as give all the documentation that they need for MCS purposes. So that's my mission this afternoon. So I'm just going to head out and see this customer. The appliance has been running for a full week now. The guys finished it last week. It is the week before Christmas. Bit of a quieter week this week. I think we've only got 3 installs going in, and brushing up any odds and sods that we need to do before we shut down for the Christmas break. So I'm going to try and keep these videos short and snappy. I'll give you a full overview of the system when we arrive on site, from the heat pump right the way through to the radiators in the system. And what the customer is to expect. Just some facts and figures on it. This is from memory. I've just had a quick look at the file. We have got a heat loss at design outdoor temperature of 4.6 kilowatts. The design outdoor temperature of this area is -3.7, and the design indoor temperature is 21 degrees. So that means that when it's -3.7 outside, to maintain an indoor temperature of 21 degrees, the heat pump needs to output 4.7 kilowatts. The maximum output of this heat pump is 4.9 kilowatts at -3.7. So we have a little bit of grace there. So there you go. 4.7 kilowatt heat demand, 4.9 kilowatt output at -3.7 to keep this customer warm. So I'll show you what the crack is when we get to site. Right, I've just arrived on site and this is the house we're heating behind me. So it is a very typical British style home, 3 bedrooms. It is in a terrace format, so obviously we've got houses that way and houses that way. It was built in 1952. It's never had central heating, so this is first time central heating. The lady that lives here has just survived with a gas fire for all of her, well, she was the second owner. She moved into it in 1955, so since 1955 she's only had a gas fire. So this is first time central heating for her. So we've, in partnership with another company, we've put solar PV on and we've done the full heat pump system. So I'll take you inside so you can have a look around. So this is the cylinder cupboard. It's a 200 litre slimline cylinder. We have piped it direct, so we've got the BLEMO valve. We've essentially got the flow coming from the heat pump to the BLEMO, and then it goes straight to the radiators and returns via the global energy filter back to the heat pump. So we managed to just about get away without putting a volumizer on this. It is open loop. All the downstairs radiators, hallway radiator, landing radiator and bathroom radiator are on lock shields, no TRVs, and then all of the bedrooms have got TRVs in them. So having those open loop radiators downstairs, as well as the bathroom and landing, and all the pipe work added together, as well as the heat pump volume, it does equate to 110 litres of free system volume. And that is roughly what we need for this unit, to prevent cycling and allow enough water volume for defrost. So we've just about got away with it, and it'll make for a really efficient system. Okay, so we're at the rear of the property where we've situated the heat pump, and if you just look above my head you'll see the solar panels. So that was done by a partner company, and that'll go a fair way to helping electricity bills for the customer. I'll spin the camera around so you can see the heat pump. So we've got it bang on the middle of the house there. It's currently running at the minute, so you will be able to hear it. Just nicely sneaked it in, so the fan is just above that planter there, so there's plenty of air area for it to get rid of its cold air. Nice big back garden. We've obviously come off the back of the unit with the flexible hoses, and then straight into some trunking and taking it to first floor level to go across to the cylinder. Now, as I was saying before, we have done this as an open loop system. all of the downstairs radiators have just got lock shields on, no TRVs. The reason why I've had to do that, well, part of the reason is because we've not got a volumizer on this, so I had to guarantee the correct system volume. So if we have all the downstairs radiators plus the landing radiator and the bathroom radiator without control on them, that gives me a guaranteed loop and volume of water to work with, so the heat pump won't cycle and it'll have enough water to work with to defrost. But also it gives the customer that control in the bedrooms. If they prefer their bedrooms cooler, they can use the TRVs in the bedroom to control that temperature, to limit it. Now, certain houses I will still put TRVs downstairs, even if I am aiming for an open loop system, if there's a risk of solar gain. Now, if you look at this house, it is in a terrace format, like I said at the front, so there isn't that much glass facing south or due south. So the chances of solar gain are quite low, so I was comfortable to do it in this situation. So there you go, that's it, and as you can tell, it really is quite a quiet unit. Right, so I thought I'd just give you a quick walk around in the property. So we're in the kitchen. That's a radiator in the kitchen. This is just to give you an idea of the sort of sizes of radiator you need with a heat pump. These radiators are designed for a mean water temperature of 40 degrees, so effectively the actual average temperature across the radiator will be 40 degrees at -3.7, that outdoor design temperature, and it'll keep them at 21 degrees inside. So if I show you, this is the biggest room, the lounge. So we've got a K2 rad there, and then we've got another one at the other side. And you'll see I'm just doing my tests at the minute. I've got my Testo smart probes on. So I've got a sensor in the radiator there, and then I've got a sensor there which is measuring the room temperature. So as you can see, 31.7 mean radiator temperature is maintaining a 21 degree room temperature in the house. So that's what we call weather compensation. So these radiators are changing temperature according to the weather outside, and because it's relatively mild today, the heat pump's been able to turn its flow temperature down to match, to make the heat emitters match the heat loss in these conditions, so the overall efficiency of the heat pump will go up. So I've just got home and I thought I'd do a quick brief overview of the system. So as you saw, it was quite a typical house you would see in Great Britain. It was 70 years old almost, not particularly well insulated. Yes, they'd had the loft insulated and double glazing done, but it was a kind of house you would see on any street in the UK. And it was relatively easy to do that installation because it was a blank canvas, because they didn't have central heating. It meant that we could just go in there and do exactly what we needed to do to make it an efficient system. So it's all new pipework, new radiators, cylinder and heat pump. The design was based on a flow temperature of 40 degrees at -3.7, the design conditions. So the estimated SCOP, or seasonal coefficient of performance, is 3.9. I think we'll get better than that. We have piped it direct, as you heard in the video, and it is open loop, so there'll be minimal losses there. We are fully weather compensated. The customer's keen to make it efficient. She understands how she needs to run the system. It is going to be on 24 hours a day, just modulating that flow temperature to keep her warm. She's got the solar panels to give her that coverage during the day to keep the run costs down. So yeah, I'm looking forward to seeing how it performs over the next year, and we'll probably revisit her and see how she's got on. If you've got any questions, just fire them down below. If you would have done anything differently, if you've got any questions on the weather compensation or that open loop design, please ask away. Positive or negative, we're open for the discussion. Everybody's learning every day. If you haven't subscribed, and you can do, please do so. And yeah, thanks for watching.